Hello all. Let's start a little bit early because I just heard that my session should finish by 7:15. So that's 1/4 left, and I suggest that we have Q&A in the bar for those who are interested. My name is Sam van Houten. I'm going to talk about a project or a platform that we've built on the Windows Azure platform to implement integration solutions. We did that for one specific customer, but we built it in a generic way. I'm going to show you how it's built, so the architectural concepts, what it does. I'm going to show a big demo, and in the end I'll also show some, let's say, lessons learned. And depending on the time left, I can also show some specific issues that we had and how we solved them by using the service bus. I'm working for Codit, which is Belgium and French company, and we focus on integration solutions using Microsoft technology only. So that's mainly BizTalk, Windows Azure, WCF, and Workflow. As I said, it's all about this integration platform and the lessons learned from that. But first, I'd like to start with an overview of the different capabilities that the Windows Azure platform provides, so the platform as a service from Microsoft, the capabilities that it provides to do integration, because you always need integration from the cloud to the on-premises systems. There's not a lot of companies who have everything in the cloud, so a lot of companies still have their ERP or databases on site. And there's 4 major components that make part of the Azure platform, and the first one is to make, let's say, hybrid connectivity on the data layer, and there you have SQL Server or SQL Azure Data Sync, and that allows you to synchronize your databases on premise, so in your firewall, in your own network, with your SQL Azure databases in the cloud, and it can do that in both directions. And then on the application layer and the server side, and a lot of messaging capabilities, you have the service bus. So before that was called the App Fabric service bus, but now it's because they want to have one big brand, it got, let's say, renamed to the Windows Azure Service Bus. And to be honest, that's really the biggest part of the entire infrastructure that we use. If you want to connect on the networking layer in a secure way between your company and your cloud machines, you can use Windows Azure Connect, and actually you can set up an IPsec, a VPN connectivity between your own data center and your servers in the cloud. So you can make them part of your Active Directory and all of that. And there's more things coming out in the coming months, so that's really something that is very interesting. And then, of course, you have security, because that's a big concern for a lot of companies. So making sure that the security on premises, so your Active Directory, can be used, these users, to log in on your web servers or your cloud applications, or using, I don't know, Facebook and all of these things. So access control service is really a big component there. I'd like to point out, and some people who were in my session yesterday will see these are the same slides, let's say, from the level of App Fabric Service Bus. So you have the Service Bus Relay, which allows you to make your internal services, so this service inside your own company, inside your own network, you can call it from wherever you are. So yesterday I showed a demo where I had a service running on my machine, and everyone who wanted could connect to that service. And how's that working? You just register on the Azure platform your own service bus namespace. You have your application, once it starts up, registering there using a unique URI, which is for you. And then once the sender calls that URI, it will get, let's say, one forwarder from the load balancer that is in front of the Azure Service Bus, and the request will be forwarded and passed as a return to the receiver. So it's like a long pole. It's waiting, your receiver, once it's registered, for an incoming message, and the return will be returned over the forwarder. What's very important here is that if you want to expose those services inside your company, using WCF or REST or things like that, you only need to have outbound connections so you don't need to open any inbound ports. So before we needed to have reverse proxy or complex firewall rules with DMZ and forwarding and all of that. Things are now simplified a lot on the service layer. The good thing is that you can also use TCP, which is typically faster. For that, you need to have some specific ports open. Again, only outbound. If that's not open, because some enterprises are pretty strict in that, you can fall back to HTTP over the ATN 443 ports. And another big component, and that's one that we very intensively use inside our own platform, is the messaging part. So you have queues. You might know the queues of the storage from Windows Azure, but there's a lot of extra capabilities with the queues that come with Service Bus. So you have more storage, you have more capabilities like duplicate detection, like sessions, like transactional submitting to the queues and so on. And you can program against those queues using the .NET APIs, using WCF bindings, or using the REST. And that's typically like yesterday in CRM Online. Or if you want to use Silverlight and all of that, you can just use REST. Then you have topics and subscriptions, and people who are familiar with BizTalk and other publish and subscribe patterns might be very interested in this, because it's actually the same as queues, but they provide the pub/sub capabilities. So you can put a message on a topic, and then you can have one or more subscriptions on that topic who have filters. So they can say, if a message arrives and it has a header with country that is Belgium, it needs to go to subscription 1. And the same thing goes for subscription 2 for the order total. And the second subscription that I show here is just one that says, I want to have all incoming messages. So you can use that to decouple your components, your applications, and to be very flexible. So if I want to add a second or a fourth component here, I just create a new subscription with the right filters, who are just SQL expressions, and you can start reading from those queues. So that was, let's say, a very fast walkthrough of the various integration components that Windows Azure provides. But now I'd like to switch to the real case that we did. So that's the integration cloud. What the capabilities are of this, I think there's 4 major areas there. So you first of all have the hybrid connectivity, because as I said, a lot of companies need to integrate on-premises or with their other SaaS applications like CRM Online, like Office 365. You want to expose web services, maybe connect EDI over AS2. So all these things need to be foreseen. So for that, we really needed to make sure that we have an extensible adaptive framework, if you want. We also use a lot of workflows, so Workflow 4, and you might have seen the session by Matt Milner, 4.5. So a lot of capabilities there we use to make, let's say, pluggable workflows that you can easily upload. And then we added a lot of extra, let's say, custom code for monitoring. Monitoring not only on the tracing level, but especially to give visibility to the end users, to the business people. Because if there's one thing that we have learned, is that Windows Azure provides a lot of different components. It's a real nice toolbox, but to build a real end-to-end solution, you need to make sure that you have the good monitoring and that you build all the visibility tools above that, because it's all technical components in this stage. And then, of course, what we did, we actually had a lot of BizTalk pipeline components from the past years, and we took that exact same logic and we brought that same logic on this platform too. A little bit on the architecture, and there's, I believe, some interesting things there. So first of all, we have a portal that is used to configure and to track messages, so to configure your flows, your messaging flows, and to view all the messages that pass through. And that's built in Silverlight, so we believe it's not dead, at least. And it's using authentication of ASP.NET. We're planning to embed ACS with ADFS so that companies can use their own corporate credentials to log on this portal. That portal is multi-tenant, so it means that the portal is shared with different customers So customers can log on, but only see their own processes. Then we have the runtime, where all the magic happens. And underlying, we are using a lot of storage and service bus queues. So in this runtime, we have a configuration and a tracking service, and that service is being called by the portal. So once you log on a portal, you get redirected to a specific configuration or tracking service, because the runtime in this stage is single tenant, because we don't want to have one customer having a process that has an out-of-memory exception and breaking another process. So we make sure that we have single tenant runtimes at this stage. What we then do is a lot of management threads who are polling on all these topics to pick up comments. Because if I decide in my portal that I want to recycle a thread or restart an endpoint or create a new endpoint and so on, I'm not doing that in a synchronous way because things can fail. You need to scale out, and there's different instances probably. So we typically push all these comments over the watchdog topic. So every action that we want to have, we put that on that topic, and then we have for every instance has a specific subscription to that. So if you add a new instance, a new subscription is added, and they also get these comments. And then the management thread is putting events to the right thread. So if you need to recycle a receiver agent, he's pushing an event to the receiver agent. And for that, we use the Prism framework for all the event aggregations. For the messaging part, so because it's all about picking up messages, picking up events and business documents from different locations and handling them, we have the receiver threads who are polling on the different locations, like an FTP or exposing a WCF service, things like that. So they pick up the files and put it always in the messaging topic. So the message is published there, and then there can be a workflow. So if you define a business process, that business process can subscribe to the specific messages, again using the properties. So if you say, I want to have a process that handles all the incoming orders of the France country, then you can say, okay, I create a workflow that says message type equals orders and country equals France, for example. And once the workflow is done, they can put it again on the messaging topic, and it's being handled by the transmitter threads. Of course, you not always have to have a workflow thread, so you can have a receiver going directly to a transmitter in a messaging-only scenario. And it's even possible to have request-response where you only have a receiver thread. So you return the response and you don't put anything on the topic. What's also very important, it needs to be extensible and customizable, your platform. So if you build something generic, and that's why we have these repositories where we can upload custom workflow activities for these messaging workflows, or we can upload custom modules for the receivers. So if you want to create a new, like we did last week, the service bus receiver who is polling on the topics or on the subscriptions, we just upload it to the right blob container on the Windows Azure storage, and we can start using it without redeploying the full machine, because that would be, of course, ridiculous. The various components are web role for the portal, and that's a small one because all the magic happens in Silverlight on the client or the services on the runtime. We have then worker role, so every environment has at least 2 roles in the production because of high availability and load balancing reasons. All configuration, authentication, and tracking information is stored in SQL Azure. And by the way, SQL Azure pricing got decreased heavily since yesterday. And then you have service bus for all the publish and subscribe things, and you have the blob storage, as I said, for your custom activities. Okay? I think a demo is perfectly suited now. So I have 2 scenarios. First is the one that we created for a data center visit. So we had the opportunity to take some customers to the Azure data center. And if you once get the opportunity, you should definitely do it. And what we do, we simulated that process of organizing such a data center visit. So we pick up a flat file from FTP, and then we parse that flat file. At this moment, the Windows Azure platform is not providing any capabilities that parse flat files or parse EDI messages. So for that, we parse it on a BizTalk server that is in our own data center. So we do a request over the service bus relay again, and we get back, so we give the flat file and we get back the XMLized version using BizTalk there. Then we promote or extract some properties, like it's for this data center, it's this company who requested, and so on. And we do a lookup to translate some data in SQL Azure. And then we start a workflow that just looks up to what hotel should we go, and we start, or we send a request on Office 365 to the right hotel. So there's 3 hotels configured, and based on the hotel, we send it in the right folder on SharePoint there. We also send it to the data center itself, so we're a request in PDF. So we create it in PDF there and publish it on FTP to the data center. And then we have a second process that loops through all the attendees and sends an email. So every attendee that is in that original flat file request gets an email. So that's the first scenario that I'd like to show now. So on disk here, I have a data center example, and I don't know if there's people who have, let's open with Notepad++, if there's people who have access to their email, because otherwise you're free to give it to you, to give it to me, your email. I don't know, Kurt, maybe? Something like this? So you can come. I should change your name then. Maybe you still need approval from your manager, but... So this flat file is just saying we will visit to the Dublin data center on this date. It's the Microsoft Belgium sub. We have all these attendees, and this is where we do the lookup. So A means it's an organizer, B means it's someone from Microsoft who is joining us, and then we have 2 people from Fabricam who will join us as attendees. So then I have the wonderful tool FileZilla. So I have my FTP here. So once I upload that one, just go to data center. I should upload it to the right location. So we have data center, and we are polling on the request folder. So I just put that file there. Then we have threads, these receiver threads that I shown, polling on that FTP location. I believe it's every 5 seconds. And you can see that in this portal. So this is the portal that I talked about, Silverlight based. And based on your login, you get to see one of these tabs above. So I'm admin, but you can also say someone cannot change the configuration, but can only use tracking. So some role-based security there. And for example, the configuration here. So where we have, let's say, business activities, and you can compare it with business processes or business flows. So that's an isolation there. And for the data center, we have one receive endpoint polling on FTP. So if we double click here, what we can see is that it's using FTP, and based on the right receiver, we can specify the corresponding properties. Like if you want to poll on Office 365 SharePoint, there's different properties and so on. What's also nice is that we have, and that's the concept that we saw in BizTalk too, that's pipelines. So we have the ability to have workflows executed in this receiver. So we have a receiver step, and you got the email. Okay, that's very nice to hear. So we have a receiver step that gets executed and where you can do message processing. So that's a workflow that we can upload. And if we have time, I can show that workflow afterwards. And the same thing is for pre-routing. There's a small difference. I won't go into details. A receiver step happens synchronously in the receiver process. The pre-routing step happens asynchronously in a separate thread. So what happened? The file got picked up. And then we said, okay, we have a process. So we have two processes who are just XAML workflows. So the first one was, let's say, the visit of the process, where we just select the right workflow here, and we put a subscription. So we say, if a file arrives on this receiver endpoint, we trigger this workflow. And what it ends up to, because at the end we have some transmit endpoints, for example, to Hotel Fitzwilliam, which is a hotel in Dublin, where we have a subscription saying, if the hotel name equals Fitzwilliam, I should receive the message. And we have the same thing for the other one, which is Conrad, but it has a different hotel name. So this is the flexible way of doing publish and subscribe. And the interesting part is then in the tracking window. So if we now do a query in the data center visit, we can see that at 6, there was a message sent, 5 attendees going to Dublin, and so on. If we then double-click, we should see a visualization of the entire workflow of the entire process that happened. So what we can see, it got picked up. Then we have a process that started. Then we have the invitation process that sends out 5 email invitations. And we can see it's being sent to the hotel and the data center. So that's the added value that we try to give. So everything is in SQL Azure, but it should be visualized in a friendly way here. Another thing that we did was, if we click here, for example, you can see that we have the ability to apply templates on messages. So you can still see the plain XMLized text, but if it's configured, we can show it in a more business-friendly manner. And same thing, for example, for the email. If you want to see the email that was sent, here we go. Okay. I think we should still go to SharePoint, by the way, where we can see that in the data center demo, which hotel was it? Fitzwilliam. So where we should see that there was a new file generated at 6 o'clock. Okay, so that's the first scenario. More focusing on the workflow capabilities and the publish and subscribe items. A second scenario was the one where we tried to do more connectivity options. So we pick up an EDI file. Who of you know about EDI? So Edifact and so on. Okay, so I think it's JSON avant la lettre. So it's very limited set of characters to send typically invoices and orders and all of that. So we pick it up, we receive it in the cloud. Again, we have it parsed on our BizTalk server in our own data center. And then it gets published to SQL Azure. So we have SQL Azure where an order database exists. Then what we did was for the salesperson who is on the road, we built a mobile application. And he's connecting to a web service that returns all these sales orders. And then he can approve or deny the order. So once he approves, the message arrives on an endpoint that we expose again on this platform. It gets routed or updated in the database to be approved or not. Then again, we send to Office 365 a PDF. We get the phone number on SAP. So I have SAP running on this machine. It's mini SAP, so there's not a lot of functionality there, but it's the same logic. So we connect to that on-premises SAP system using the service bus relay again. So there's a service that I just run in a console app to make it very visual, running on my machine. So from the cloud, we will call and look up the phone number. I'm not saying it's a very real case scenario here, but we call and get the phone number, and then we will send an SMS to the right customer to say that his order was approved or not. And we also send an email after that. So let's show that second demo. For that, I created an EDI file generator, and let's give a customer name with order number. And let's order some articles, maybe some extra birthday cake. Okay, like that. So the message was created here, and this is what EDI looks like. So very compressed type of settings. So you can see the customer name, you should see the cake somewhere. So that's EDI, and let's remove the old one. If we then again upload the order, which one was it? EFE. So this one, if we then upload it to, again, the EDI location on FTP, it will be picked up again by these threads in the cloud. It will be parsed on premises, and it should be added into this SQL Server database. So getting back and switching to the order scenario now, we can see that now there was an order picked up, live demo, and the status is new. So if we then go to this, and this is a fancy thing here, a nice webcam. So this is the application where I need to log on. It looks very real, doesn't it? And then we do a request for all the orders. So it now goes and calls the service on SQL Azure, on Windows Azure, and connecting to SQL Azure there. We can click on that order. We can see the details like, oh, there's birthday cake, and we can approve. Once I approve, I'm expecting to have my workflow in the cloud calling this application. So this is the application exposed to the cloud over the service bus, as I showed with the relay stuff. And this application is then connecting to my SAP. So the most sexy ERP application you can have. And I have some different customers configured there. For example, Logix, that's the one that I'm using now. And if you look to the right, you can see, if you want to call me, this is my number. So let's approve this one. So it was approved, and you can see the order disappears. You can see the message was sent from the cloud to here. We did a retrieval from SAP, and I'm expecting to see on this mobile application within, let's say, some seconds, here you go, that my order was approved. Live demo. What I also should see is, again, that on SharePoint, the order demo here, we have a file created, as you can see here. Which is a PDF. It's not the most sexy PDF, but this is the PDF that we generate, and for that, by the way, we use XSLFO, so formatting objects. It's like HTML for text documents, and then we have a parser in that workflow that processes that XSL to a PDF document. Again, showing what happens here, we can see that instead of new, we have an extra line which says the order was approved. Double-clicking here should show again what happens. So you can see that the order was retrieved as a service call. We do a query on SAP, and then we send the SMS, and we send these other items. And by the way, you can see that I'm also invited to the data center. To go back to the configuration part here, this is where you can see the WCF part. So we expose an endpoint on the fly by exposing, this is basic HTTP, so you configure the binding, you configure the address, and then we use the endpoint name. So on Windows Azure, you configure a public endpoint, and we link it there, and then we build the URI based on that. And we also allow you to specify a WSDL prior to that, or you can use an interface as your contract. So you can use a WSDL approach or the contract of WCF. What you also have is, and that's a very small thing, but you can set custom icons for all these applications. So let's say that's the overview, the demo of this platform. By the way, you can also see the monitoring side, so where you can also see more of a system administration part, all the threads that actually happen. So these are all threads, a receiver thread. There's 4 transmitter threads in this same agent. So you can stop and start, and you can see some items here. Okay? Any questions so far? Let me then switch to the lessons learned, because I believe that's also important. And again, this won't be valid for every single application, but it's some feedback that I believe that could be valuable for people who want to start working on Windows Azure. So some things that we have learned, and sometimes the hard way, was you should always test with multiple instances, especially with worker roles and all of that. So roles that do polling or that connect outside and all of that. If you always use one instance locally, F5 and all of that, there's a lot of things that you will look over. For example, initialization tasks. So if a role starts, you can write some initialization code, and that's what we do to create all these entities on the service bus. That happens on your on both of your instances. So we were trying to create the same queues at the same time, and they were competing, and we were getting errors, and that didn't went well. So for that, we did a pattern where you just have you try to lease a blob, and the first one that leases the blob that gets, let's say, the lock of a blob. It's just an empty blob. He can do all the initialization, and the other one tries every X seconds to get that lease. So once the first one is finished with the initialization work, he releases the lease. The other one gets the lease and says, "Okay, now we can start with the real threads." So that was one of the patterns that we did there, and also the queues. So it was very easy in the beginning. Oh, we will restart this agent, just do a call, recycling the threads. But then you start with 2 instances. Oh, we need to be able to call to the 2 machines. And that's why we inserted that topic with subscription algorithm there. So I believe that's something that's very important, and it's not difficult. Just change 1 to 2, and you can find it out from the beginning then. What we also see that, I think we're working on this since 1.5 years already, and during that period, there's been a lot of changes not only in our platform, but more changes in the Windows Azure platform itself. So Service Bus got through a lot of changes, computers changing, and there's a lot of things coming. For example, a lot of things that we have seen here, EDI parsing and flat file parsing, that's coming. As I shown yesterday in the CRM demo with the bridge, you will have a mapper in the Windows Azure platform. You will be able to do EDI and all of that. So for that, it's very important if your solution is designed to last long, yet to take care of that and to design for change, to make sure that you abstract a lot and that you can just change the implementation of your components without touching the entire platform. It's different up there. If you want to see what's going on, you can log on with remote desktop, find your trace files. You can, go ahead and check your logs and all of that. But it's very important. And since we are using System Center anyway for our own servers and for the BizTalk servers we have, we decided to use System Center, so SCOM, with Windows Azure 2. So it's not the most enhanced pack, but it's connecting to the diagnostics account. It's getting all the events, and you can set up alerts. In theory, but we don't see the need yet. You can monitor the performance, and you can see, oh, my services are exploding, like they are peaking to 80 percent of CPU, for example, for a long time. Let's spin up an extra instance. So that's all possible. We don't use it now, but we know that we are ready to do that whenever we might have the requirement to do so. Another one was the service bus publisher. So what we did there was live tracing. So sometimes while you're testing in the cloud, you submit a message and you want to know what's going on, and then you not always want to wait until the diagnostics arrive and so on. So we have a tracer that you can configure. So once your local application starts up, it lets the tracer in the cloud know, I'm listening. And then he starts getting all the events live over the service bus relay. So all the events are going in the screen. And you can really see, I submit the message, this is what happens. And that's something that I believe is very important. So make sure that you know what's going on there. One of the things that I heard, maybe too much sometimes, it works on my machine. And I've been like that in the past too. It works on my machine, and it doesn't work on the server. So it works on your single box machine, and it didn't work on that cluster and all of that. The same goes for cloud, and it's maybe even more true, because you have these development emulator, the dev fabric, and that's a simulation. So it's not having the full fidelity with cloud, not at all. I mean, it's evolving, it's getting better and better, but there's a lot of things different. Accessing a file is different because blob against file, and if you forget about that, you can still access a file from your dev fabric, and you won't get an exception and so on. The network is different. You have the full endpoint configuration there, and locally it's totally different. And for that, I believe it's important to have a very part of your application lifecycle. Have a very iterative deployment, so where you automate the deployment if you can. There's a lot of build tasks where you can have your application uploaded and so on. And also the testing. So if you can automate your testing linked with your deployment, I believe that's something very important. Because you redesign a lot, you change a lot, and you want to avoid regression as much as possible. And then caching. We all know that there's the Azure cache from the service bus. To be honest, that's pretty expensive at this time. That might change over future. And you don't always need that. It can be very handy if you have these large systems with bookstores and all of that. But we only need to cache the configuration and some tracking data and so on. And for that, it's just caching in memory on all these machines. It's not megabytes, but it's very important. You don't have to look up all the time in your databases, in your data stores. So I believe that's something very important. Another one is the connectivity issues. So one premise is if you connect applications with your SQL, if things go wrong, if a connection fails, it will probably fail the next time again because the server might be down. In cloud, it's different. It happens a lot that you want to try to write something on a topic, or you read something from a SQL Azure database, and it happens every now and then that there's a glitch, like you get an error back, server too busy or whatever, and you just need to design for that. So you're doing a retry, and chances are big that the next retry, it will work immediately. So that's something that you need to handle on all levels. Every time you go outside of your, let's say, isolated environment, SQL Azure, file connections, FTP, polling on all these receivers, always try to handle connectivity issues. And there's a very interesting application block, the transient fault handling block. So that was released by the Fabric CAD team, and it's now publicly available. So we really leverage that for all the connectivities against Service Bus and against SQL Azure. And as I said, I explained it already a little bit in the beginning with the modules and the Prism framework there. So you need to design for extensibility, at least in this type of application. So we need to be able to upload a custom activity, a custom action that needs to happen. an extra receiver. We need to just be able to upload it, recycle the right thread, and things should work like that. So for that, we have all the workflows running in their own application domain, so we can recycle that very easily, get all the references and so on. So that's something that I believe was very valuable to make it an extensible platform. And then I have some specific tips, 2 tips, or maybe 2 issues that we encountered, and 2 possibilities or 2 capabilities of Service Bus that we used to solve them. So this is maybe a little bit more technical than a 200, but I won't dive too deep into the code. So the first one was suspending and resuming a message. Imagine that you have that my service here was down, my SAP service, because my local network is out or my BizTalk would be out, so my message would fail. We would do the retry automatically. It would retry for 3 times by default. And when that fails, we suspend the message. And then we need to be able to resume that message, so to have it delivered and processed again, because we can see the error in SCOM, and we can say, okay, the server is back on, let's resume. And for that, we use the Service Bus deferring of messages. So what happens, we receive a message with peak lock, and that means you receive it, you have a lock of the message, but the message is still on the queue. You do your work, and whenever the work finishes successfully, you say, okay, I complete the message, and then the message is received, all is well. If something fails, like that service is down and you've retried, you can say, okay, I will suspend the message, and for that you say, defer the message. And you get an ID for that message, a long ID, and we store that ID in the database, and whenever an administrator through the portal says, oh, this is a suspended message, let's resume it. We put on the watchdog topic, so the management topic there, we put the trigger saying, please resume message with ID 4. And then that management thread will call the right agent and say, you need to pick up message 4. And then he can go with that specific ID and get it. I want to have that message, and he tries to resume it. If that would fail again, the message will be still on the queue. So that's the way we work for the suspending of messages. And I have my solution available to give a small demo. It's nothing to do with the platform itself, it's just the capability of the Service Bus that I want to demonstrate now. So let's not connect to DFS because of the network latency here. So what I have a receiver and a transmitter. And let's just start them up. So this is the, okay, I should have changed the name. On the right you can see the receiver, and on the left you have the transmitter. What it does, the transmitter is putting a message on a queue. So if you want, I can show you the Service Bus Explorer, which is a tool that shows all the queues. So let me connect to my namespace, which is this one. And if it's connecting, it's now getting all the queues, all the topics that are in that specific namespace. So a namespace is a collection that belongs to yourself with all your entities. So queues, topics, all of that. So I have this resume queue here. It doesn't, it has a message, it seems. But that's the one that I forgot the ID about. And what I do, I just put a path on the queue, and the receiver will pick that message from the queue, and it will try to write a file in that path. In some cases, that path doesn't exist, and then I will try to resume, suspend the message. So this file itself here exists. So if I send it to the queue, And by the way, I'm sending in a transaction scope, so he will ask me, do you want to commit, yes or no? If I don't commit here, the message is not on the queue. So let's commit. The message should be on the queue, and if I here say process next message, it's now connecting to that queue in the cloud and retrieving the comment. So he's getting the comment, and it should write the file, as you can see here. Very straightforward. But what happens if I try to send a comment to this queue of a path that doesn't exist? You can see I'm suspending the message, and I get this ID. So that's the ID we store in that database, 7. Let's try maybe another one. And we should see that this one is working again. So if I now want to, I go back to my portal and I want to resume a message, I can give that ID, 7, and that's what we store in this database. Of course, I can do a resume, and again it won't work. If I now create this new folder, and I do a resume, we should see it works. And if I now want to try a resume, but I'm not catching the exception, it explodes after some time, like this. So this is not production-ready code. If you're interested in the code, let's go very, very fast to the right lines of code. So this is the receiver. So where we just say, so we have the messaging factory, we create a queue client, and then we say receive the message. And we can receive the message with a specific number. So that's for the resume action. And if you want to defer, and I believe that's this location, again we have the namespace, we create a queue client, we say receive a message. If we receive a message, we will handle it. And what happens if the directory exists? We write the file and we complete the message. So that's the transactional behavior. We have a lock on the message, we write the file and we complete the message. Message is gone. In the other case, where we see the file or the directory doesn't exist, we add a message to the logging window and we defer the message. And we defer the message and we keep the sequence number, because that's the one that I will use once we resume. Okay? Another one was the polling for messages. So with BizTalk server, for example, if you connect to FTP, you receive from FTP, you need to have some clustering, because a lot of FTP servers don't support locking. So it can be if you have 2 machines polling at the same location, that the same file would be retrieved twice, and you want to prevent that. So with BizTalk server, we just solved that by making it an active-passive cluster, so that you only have one of the 2 machines polling on that FTP. If one machine goes down, you still have the high availability, because it would fail over. Clustering is not available here, so the clustering concept. So what we have a different way of working. We said, okay, let's just poll with all these machines that we have, and mostly it's 2 only. We poll on FTP on file, and if we find a message, we put it on a queue, the trigger queue. Just the location of the message, not the body, so just the location of the message. And then we have different threads for that receiver, polling on that queue. And if they receive the message, or the trigger for that message, they pick up the message, handle it, and process it. What we use on this queue, duplicate detection. And that's a feature that is available that prevents you from putting the same ID twice. So what happens if thread 1 picks up file 123.txt, it puts it in the trigger queue. The second thread picks up file or detects file 123.txt. He tries to put it in the trigger queue. He won't get an exception, but there won't be only one message with that ID. So that's a duplicate detection way. And let me show you how that works. So we have a duplicate check queue, and it requires duplicate detection. I don't know if you can see that well in the back, but there's a check requires duplicate detection. You can also specify if it needs sessions and so on. But here, if you enable that, a message will be unique. By the way, you can specify how long that duration should take. So if you submit the same message on this queue with the same ID after 10 minutes, it will work again. There's one important thing, by the way. If you have a timeout of 10 minutes, and in that, or after that 10 minutes, the message with ID 1 to 3 is still on the queue, and you try to write it to the queue, you will have 2 duplicate messages. So that's one thing. If the timeout expires, he won't check the message again. Now switching back to my application here. I have a transmitter and a receiver. Oh, that's the wrong one. So I have a console app listening on that queue, and I have a duplicate check or a transmitter. So if I submit message with abc.txt, so these are old messages. You see I test quite a lot. Submitting that message, you can see the message was picked up by that receiver. Submitting a second message, you can see the message is picked up. If I now send the same message again, abc.txt, you see in my transmitter, I'm not getting any exception, everything is fine, but the message was not put on the queue. So again, if I put something else here, it gets delivered. So the queue itself filters out all the duplicate messages, and that's something that you can use in different patterns, and that's the one that we use. We have all these different threads pulling on or listening on these file or FTP locations. They put the file name in the queue as message ID, and if the second tries to put the same file, it will be fine for him, but it will be blocked there. Okay. There's one thing that I want to show, and that was depending on the time left, before I get back to this slide. And that's how we build these workflows. So how do we build the workflows for this messaging platform that we've built? So let's open this. And this is connecting to the tfspreview.com. So that's TFS in the cloud, something very interesting that's coming. So there's a preview available there. If you, for example, go to the order demo, you can see that there's different, for example, this one. So there's different workflows. So we create a workflow with some activities. Let me zoom a little bit. So for example, getting the customer phone number, that was the activity that behind the scenes connects over the service bus to my console application. It promotes or gets the phone number back, and then we say, okay, to the message, let's just add that to the context so that we can do the publish and subscribe on it. We also need to specify the prefix for the country, define that the next action that should happen is SMS and so on. Every workflow that we have accepts an argument, an input-output argument of type message. So that's an internal type that we use that wraps the message. So every workflow retrieves the message, can do whatever he wants with the message, and returns that same message. So you can change the message body, you can all of that. Also, one thing very important here, it can be that messages are larger than the 256K, which is the limit of a message on the queues and topics of service bus. If the message is higher than that, actually we always write it to blob. If the message is lower than that limit, we keep the message body in the message on the queue, because we don't need to retrieve it all the time from blob storage. But if it's larger, we keep the reference to the blob storage in the message, and we need to retrieve it in every step. This, for example, is how you can configure custom activities with some custom UI. So here we can specify the mapping that needs to take place, but we can do database lookups and all of that. So this is just a pipeline component that existed on BizTalk server and that we actually migrated to this solution. So we can have an easy migration. Here, for example, the PDF generator is again a component that you can just drag from the toolbox, and that will generate the PDF items. So it's a very modular way of working. And if you then want to upload everything to the cloud in the configuration part, you can just go to the workflows here. And add your new workflow. So you can just browse to your workflow that you just created, you can upload it, and then you can start using it. If you want to update the workflow, you just double-click it, upload the new workflow, and the runtime will detect, oh, there's a new workflow, so let's now recycle the app domain and reload that workflow with all the references. So that's the way we isolate the different receivers from each other and have their own app domain with all the references. I think we can finish with the session summary in this case, because I think you'll all be happy to be able to leave home early. I think we can say that Azure is a really extended and very powerful toolbox with a lot of components. Maybe one of the biggest strengths or advantages of Azure compared with some other platforms might be the connectivity options, so the hybrid connectivity. I believe Service Bus is very important there, but also the network layer. So Azure Connect, we can connect from the cloud to files on premises in a very secure way, in an IPsec tunnel. So I believe that's a big differentiator there. And of course, you have the scalability. To give an example, we configure the creation of an environment just in PowerShell. So if people, like we give training on this platform internally, and if we have like 8 people coming to get a training, I can just fire up 8 PowerShells, and let's say after 15 minutes, everyone has his own environment. Training is finished, we throw everything away, and it doesn't cost a lot of money. So it's very easy, it's very flexible, it's very agile to work with all of that. And I think if you have scenarios, just start and build your scenarios on the platform. And the hybrid connectivity, that's really something that I believe is, in most of the real world scenarios, one of the most important capabilities and one of the most difficult things to solve in a lot of cases. So I think, unless there's questions, I'm still available, of course, to answer them. Otherwise, I thank you. And I can say if you want to find more resources and all of that, this is where you can go. And otherwise, have a good evening then.